Now, when I did the video on the Amstrad 7070 cassette deck, I did comment that I hadn't got any way of checking the wow and flutter. And after doing the video, I sat back and thought about this, and I thought, well, I don't have a wow and flutter meter, but I do have an oscilloscope and I do have a frequency counter. So I went online, and apparently you can buy test tapes for cassette decks which have precision recorded test signals on them, and they're not horrendously expensive. So I thought, right, well, I'll get one of those and we'll just give it a go and see what this thing actually performs like. Now, this is in no way an accurate calibration or anything like that. My old Ameg oscilloscope and my Black Star frequency counter are probably as old, if not older, than the Amstrad cassette deck, and they've not been calibrated in donkey's years. What I'm really looking for here is really to see if there's any variation in the frequency and amplitude of the played back tone. So I'm hoping that the frequency counter will give us a good idea of how slow or fast the deck is, but obviously, you know, as it's not been calibrated, it's not going to be accurate. But I thought we'd give it a go just to see how this 45-year-old cassette deck performs. I believe the first frequency is 3 kilohertz.
Calibration tone. 3000 hertz.
Well, that's interesting. The amplitude is varying quite a bit. Let's move you over to the scope. Very odd. But the frequency is low. We'll go over to the frequency counter now. About 100 hertz low, but it's constant. The reason it's changing is because obviously the amplitude is changing and it's not locking onto it, and every now and again it fades out. But yeah, definitely, what, 100 hertz low, if this is accurate. But it's the amplitude variation that's very weird. I don't quite understand what's going on there. Oh, setup wise, I've got the frequency counter and scope connected to the right channel line out, and the speaker connected to the left channel line out, so you can actually hear what's going on. Okay, let's move it on to the higher frequency. It's been playing for a while now, and the volume level seems to have stabilized a bit. It's still varying a bit, but it's more constant than it was. Frequency is quite low, 2.899, 2.9 kilohertz as opposed to 3, but we'll try it on the higher tone. Right, we're going on the higher tone.
3150 hertz.
So this should be 3150 hertz, 3.15 kilohertz. And according to the frequency counter over there, we are under by about 100 hertz, which ties in with the previous reading on the lower frequency. Still quite a variation in the volume though. It's not as bad as it was, but it is definitely going up and down. Although the frequency is fairly constant, which I mean, that's good. The last thing you want is the frequency wobbling around. Okay, well that's enough of that. Let's go, the next one I think is 400 hertz, which is much, much lower. So we'll move on to that.
Test tones. 400 hertz.
the scope so we can actually see this. There we go. Well, that's interesting. As you can probably see, that's pretty much rock steady on the amplitude and on the frequency. So that's bizarre. And as you can also see, it's about 15 hertz low. This is not terrible. And don't forget, we are talking about a 45-year-old deck here. So obviously the speed of the motor needs to be tweaked a little bit, which you can do. There is an adjustment for that. So as the best sort of certain from output point of view, the best signal is at this 400 hertz range because it's constant volume and we're getting a pretty constant frequency. I'll probably adjust the motor speed here and we'll try it on the others. Well, there doesn't appear to be any speed control on the motor. So that's out. But I did take the drive belt off, which seems okay, but anyway, I measured it and I did actually have one. So I've changed the belt. That's about the only thing I can do with regard to speed. So we will try it again on the 400 hertz range. Well, that's interesting. That's very interesting. So let's wiggle it around a bit. So all I've done is change the belt. And that's a lot closer to 400 hertz than it was before. Fairly constant tone on the 400 hertz range, which is pretty good. Not moving up and down an amplitude at all, which is what we want. So we'll look at the scope. Again, a nice fixed constant waveform. So we're about 4 to 5 hertz low on the frequency, but I'm not going to worry about that. Okay, let's go back to the higher tones and see whether or not we're still getting this amplitude modulation. Now I've changed the belt. Okay, this is the 3.15 kilohertz tone, which again is still varying in amplitude. But we do seem to be a lot closer to the right frequency. That should be 3150. So we're about 50 hertz down on a 3150 signal. But as you can hear, you know, the amplitude is still varying and you can see it on the scope. It's strange that it does it at the higher frequencies but not with the lower. So let's go back to the 3K tone now. Right, I wound it back into the 3K tone area, which again is still varying amplitude, but since the belt change it looks like the frequency is a bit better. Yeah, we're still 50 hertz low, but that's better than it was. But it's this weird change in amplitude that I can't suss out. However, that I'm quite pleased with that. That's not bad at all for a 45-year-old cassette deck. So I'm going to leave it there on this one. Hope you found this interesting, and thanks very much for watching. Cheers.